The end behavior of a polynomial is how the ends of the graph of the polynomial behave. So yes, I just defined end behavior using the word ends and behave. So it is how the ends of the graph behave. Mainly the left end and the right end. The end behavior is determined by the degree and the leading coefficient. So on Friday we talked about identifying the degree and the leading coefficient of a polynomial. Now we're going to look at, is the degree of the polynomial, the degree being the largest exponent, is the largest exponent an odd number or an even number? And then we're going to look at, is the leading coefficient a positive number or a negative number? Let's talk about leading coefficient first. So on the left side of this chart are examples where the leading coefficient is positive. And what I want you to notice is when the leading coefficient is positive, the right side of the graph points upward. The leading coefficient controls the right side of the graph, the right end of the graph. And then notice on the right side of this chart, when the leading coefficient is negative, the right side of the graph goes downward. If the degree is odd, notice on the top part of this chart, both of these have an odd degree. That means your largest exponent is like 3 or 5 or 7 or something like that. If the degree is odd, the two ends point in opposite directions. So odd degree, the ends point in opposite directions. I apparently can't spell opposite today. Opposite directions. So leading coefficient positive, the right end points upward, but because it's an odd degree, the left end then points downward. Leading coefficient negative, so the right side points downward. Because it's an odd degree, the left side then points upward. Even degree, the two ends point in the same direction. So a positive leading coefficient means the right side goes up, the left side also goes up. If the leading coefficient is negative, the right side goes down, the left side also goes down. All right, turn the page and let's practice leading coefficient, degree, and behavior. Okay, describe the end behavior of the graph of the function. Make a sketch of the shape of the graph. So in this first polynomial, my largest exponent is 4. So I'm really the most concerned with this term, negative 0.5 times x to the 4th. The degree is 4, and 4 is an even number. So my degree is 4, which is an even number. My leading coefficient is negative 0.5, which is a negative number. Okay, I always start with the leading coefficient. The leading coefficient tells me what the right side of the graph is going to do. So a negative leading coefficient means the right side of the graph is going to point downward. Then I look at the degree. Even degree, the two ends have to point in the same direction. So the left side is also going to point downward. If you want to leave your sketch like that with a break in the middle, that is totally fine with me. This tells me that you know that both ends have to point downward, and something's going to happen in the middle between those. Because this is a 4th degree, it's probably going to end up looking kind of like an upside down W or an M. But you don't have to write that middle part if you don't want to. In B, here's our largest exponent term. This time the degree is 3. Is 3 even or odd? Odd. And is our leading coefficient positive or negative? Positive 0.25. So positive leading coefficient means the right side of the graph is going to point upward. With an odd degree, what is the left side of the graph going to do? Point downward. And if you want to connect these somehow, you can. If you want to just leave it as a down arrow and up arrow, that works. So you can write this either way. All right, try C and D on your own. When I memorized these, I thought about the leading coefficient first. Leading coefficient positive, positive up, the right side goes up. Leading coefficient negative, negative down, the right side goes down. Then I remember odd opposite and even same. So on C, the leading coefficient is positive, so the right side goes upward. The degree is even, so the left side has to do the same. In D, the leading coefficient is negative, so the right side goes downward. The degree is odd, odd opposite, so the left side is going to point upward. Now, why in the world do we even learn this? This is another tool that you can use on ACT tests, EOC tests, your final exam, whatever it is. If you have to match a polynomial to its graph, if you can identify the degree and the leading coefficient, you can identify which graph matches that polynomial much quicker than you could if you had to type it into your calculator, have your calculator graph it, and then compare your graph to your pictures that are given to you. In example 4, describe the degree and the leading coefficient of the polynomial. I don't care what the exact numbers are. You really can't figure out the exact numbers unless you do some kind of complicated math. So let's just think about degree odd or even, leading coefficient positive or negative. In example A, the two ends point in opposite directions. What does that mean about the degree? It's an odd degree. The right side of the graph points upward. What does that tell us about the leading coefficient? Positive leading coefficient. How about number 8? Even degree, because they point in the same direction. Negative leading coefficient, because the right side points downward. Okay, now we get to graph. This is where the fun part happens. We are going to use the calculator to graph for us. So let's start by turning on the graphing calculator. Now keep in mind that if you're using one of my calculators, who knows what was done on this calculator before you got to it. If you ever turn it on and you're like, what the heck is on the screen? Try pushing second mode, and that will quit. You see quit is written right above mode. So second mode, that will quit, and that will take you back to just a blank screen. Okay, so what we would like to do, you have to push second mode, not just mode. Okay, in the y equals button, which is the top left button on your screen, if somebody else has been using your calculator, there might be a function in there. Clear out that function, and let's type in our function. Negative x. Do you guys know where the x button is? The x button is diagonal down from the second button. Do you see my little cursor right there? It says x comma t comma theta comma n. So diagonally down from the blue button is the x button. X raised to the third. If you raise x to an exponent, your cursor is stuck in the exponent until you push the right arrow to move down out of that exponent. Squared plus 3x minus 3. Once you have that function entered in there, you can push the graph button and watch your calculator graph this function for you. It'll churn on it for a little bit, and then it'll start graphing it. Okay? Okay, now why does it look like that? Let's take a look at what the degree and the leading coefficients are. The degree is 3. That is an odd number. Oops, I should probably use a pen. and the leading coefficient is negative, so the right side of the graph should go downward, and the left side should point the other direction. 10 years ago, we didn't use these calculators, and we actually had to pick x values, plug them in, find points, plot the points, and then try to connect them to make some sort of a graph. We are going to let the calculator do that work for us. So on your calculator, push second and then your graph button, and it will take you to the table. We are going to record any points in this table that are going to fit on a standard -10 to 10 graph, because that's what we're going to do. You can use the up and down arrows to move up and down on this table. So I'm going to record the points -2, 3, -1, -4, 0, -3, 1, 0, and 2, -1. Do those match everybody else's? Did I do something wrong? Okay. Now, some of your calculators are already set up this way, but I want to show you a trick so that you can see the graph and the table at the same time. If you push your mode button, your screen is probably going to look a little bit different from mine because your calculators are newer than mine. But partway down the screen where you see the word full, if you look to the right from the word full, there's horizontal and then GT, or your calculator might actually say graph table. If you move the arrow over so that graph table is highlighted and hit enter, now when you click on graph, you will see the graph and the table on the same screen. If you want to move up and down on the table, you still have to push second table to get your, oops. No! So if you want to move up and down on your table, you still have to push second graph, and that takes your cursor over into the table, and now you can move up and down to get x and y values on your table. Okay, let's plot these 5 points and see if we can connect them into a graph. If we didn't have the graphing calculator to guide us, how the heck would we connect these points together? This is where using what we know about end behavior can be really, really helpful. We know that the right side has to go down, the left side has to go up, but we also have our graph that we can look at as a guide. So it looks like the graph is going to come down through this point and then curve up and kind of around and then back down. So there's our sketch of our graph. Once you get this function entered into your calculator, I like to go to second table, so second and then the graph button, because then I can adjust the table. I can move up or down to get which values I want. -2, 12 would be off the graph, so I'm going to ignore that one. I'm only going to record the points that are within -10 to 10, because that's what I can fit on my graph without changing the scale. So I only got to record 4 points. I notice that the degree is even and the leading coefficient is positive. So my two ends have to point upwards. So even if I didn't have this picture on the graph screen to help me, I would know that from these side points we have to go upward. But using the graph to kind of guide us, it looks like the graph comes down and then goes up to this point and curves down and then back up and makes this kind of wobbly looking W shape. Okay, we aren't going to do C and D because I don't think we need to. If you need any help with the graphing calculator, please let me know.